In this presentation, we will learn about elements and how to represent them with symbols. We already know that materials around us, matter around us, are made up of atoms, and we learned about the structure of an atom, about the subatomic particles. Now we will learn how to classify the matter into the types based on the atoms that it is made up of, right? So we classify matter as pure substance and mixture. So we already learnt in our 6th standard that matter is classified into 3 types: solids, liquids and gases, based on how the atoms are arranged, how the space is there in between them. Similarly, based on the chemical properties, we classify the materials around us as pure substance and mixture. So we say that elements and compounds are pure substance. Why? Because elements are made up of similar type of atoms, and whereas compound, though they are made up of different atoms, as you see here with 2 different colors, atoms represented here with different colors, they chemically combine and they cannot be easily separated by physical or chemical methods. So elements and compounds are pure substance, whereas mixtures are said to have their atoms mixed in any proportions, which we have already learned in our 6th standard in detail, how to separate the mixtures by various methods. So this year we are going to concentrate on elements and compounds in detail, which are nothing but the pure substances in chemistry. So it is based on the atoms which are present in them, right? Type of atoms. So what is an element? It is a substance that contains same type of atoms. It is a pure substance which contains same types of atoms. It is similar type of atoms. Now let us consider an example: gold, a gold bar. When you zoom in and just look into the particles, the atoms which are present, which is represented here like an yellow ball. So as you see, it is made up of similar type of atoms, which means they are similar in the number of subatomic particles, number of protons, electrons, mass of each atom will all be similar. So we say that gold is an element. Similarly, you have another example of nitrogen, where it is represented with blue balls, that is atoms. Two nitrogen atoms have combined to form a molecule of nitrogen. So they are similar in all properties. That is why you have a representation here with the same color, blue color, right? It doesn't mean that it will be blue in color. It is just for you to understand that they are similar atoms, right? So since they are made up of similar atoms, which are same in all ways, properties, size and so on, we say that these are elements. So gold, nitrogen, oxygen, sulfur, carbon are some of the elements that we are already aware of. Now let us consider an example of a jewelry made up of gold. So we know that gold alone cannot be made into a jewel. So it has to be mixed with copper. So it is alloyed with copper. We say the term as alloy. That means we mix 2 metals. So usually to make a jewelry, gold is mixed with copper, and so we call it as a mixture and not an element. If you consider a bar of gold, we say it is an element, but here it is mixed with copper, so it is called a mixture, right? Now let us consider an example of a compound where you can see the representation of atoms which are different from each other, and that is why you see a difference in the colors. So it is 2 atoms of hydrogen and 1 atom of oxygen. So 2 blue color atoms, here red color atom, which means they are different atoms. So hydrogen with atomic number 1, oxygen with their atomic number 8, that is number of protons are totally different. So they are 2 different atoms which are chemically combined to form a molecule of water, right? So it is a compound and not an element. Water is a compound. And can you give one more example of a compound that we use in our kitchen in the name of table salt? What it is? It is sodium chloride. Am I right? So it is nothing but a compound with sodium and chlorine. So 2 different atoms, which is a compound. Now let us consider this slide where you have a tabular column. Yes. So have you seen this before in your chemistry books? Are you familiar of this picture? Yes, it is the periodic table of elements, where we have more than 100 elements arranged in an increasing order of atomic number. So as you see here, hydrogen on the top with atomic number 1, followed by helium here on the extreme right, and then again lithium, beryllium, boron, carbon. They are organized in a particular fashion so that we can learn the properties and then compare and contrast them. So we usually group their elements or group any substances in chemistry or science in order to study about them. So again here periodic table is nothing but the elements are grouped in some fashion so that we can learn about their properties in detail. So we will learn about them in our future video. So it is nothing but the elements which are just arranged in an increasing order of atomic number. So what makes these elements different? It is nothing but the atoms that make them. They are the different number of protons, which is the different number of atomic number, right? So they have different atomic number, they have different number of protons, which make them different, and that is why we have a different name for each, and they are represented with different symbols. So each element is represented by a name, which is a unique name for each element. So if I say hydrogen, which means I am referring to a atom with atomic number 1. If I say carbon, then I am referring to an atom with atomic number 6. So it is a unique name for a particular element, and it has a unique symbol to represent. Just for simplicity, to represent the element's name, we have an abbreviation. So they are the standard set that we have to follow, and we should use only capital letters if you are going to just write the first letter of the name. So now most of the symbols which are very common, we have their symbols derived from the first letter of their name. So as you see here, hydrogen H, carbon C, fluorine F. And some elements have their symbols derived from the first two letters. So as you see, lithium Li, Al, it is for aluminium, He for helium. When you write these symbols, you should remember the first letter should be capital and second letter should be small. And some elements have their symbols derived from the Greek letter, Greek words. So Pb, as you see here, is not there. The letters P and B is not there in this word lead. It is derived from its Latin name called plumbum. Gold is, symbol is Au, it is derived from its name aurum. Silver, symbol is Ag, derived from its name argentinum. So you will learn about these in detail in the future classes. So you should just remember some elements have their symbols derived from their Latin and Greek names, right? So we have certain set of rules as we discussed in a previous slide. We have to write the first letter as capital, second letter should be small, and for some it is derived from their Greek or Latin name. Sometimes it is the old Latin name that is used, right? Latin is a language, Greek is also another language. So we derive the symbols even from the Latin names, and it is an identity of a particular element. And we have the rules which are governed by an organization called IUPAC, International Union of Pure and Applied Chemistry. So what is the acronym? IUPAC, International Union of Pure and Applied Chemistry. It's just like an SI units. We have certain rules to be followed for writing the symbols, formulas in chemistry, which is ruled by IUPAC, right? Now let us learn the first 20 elements in a periodic table with the symbols. And we have one more column here, the last column, which is valency, which you will learn in your next class, the next week, right? So just learn the name of the element and the symbols with their atomic number. And I will teach you an easy mnemonic to remember the first 20 elements, which is nothing but Ahi, Li, Bi, Bak, Nafni, Namji, Alsi, Pasukal, Ar, Keka. I'll repeat Ahi, Li, Bi, Bak, Nafni, Namji, Alsi, Pasukal, Ar, Keka. So K is potassium, Ca is calcium. So now almost all these elements have the symbols with either the first letter or the first two letters, but you have an exception here, sodium, Na, potassium, K. Only these two elements you may go wrong, just go through that properly. So I'll repeat, sodium, Na, potassium, K, whereas the other elements you have either the first letter or the first two letters as their symbols. So learn this thoroughly, learn the spellings of phosphorus, potassium carefully. Thank you.